Yeah, so maybe I will use the chance to start. So first of all, welcome everyone. Welcome back to the third day of our summer school. Maybe a little bit to the structure of today. So after the first 2 days that were mainly from the traffic engineering point of view, we are today going a little bit into the mathematics of things. So Anita and I will give the lectures and exercises today. And we are both mathematicians, so we want to show you a little bit from what everything looks like in our point of view. I already gave you a short idea on Monday, but this today will be a little bit more in depth.
But Alex, we will keep the mathematical part rather low.
Yeah, exactly. So just what I wanted to say. So nevertheless, we will not have part to cover the deep mathematics of mathematical public transport planning today. So we will try to keep everything rather hands-on so that you can also play around with stuff a little bit. And yeah, if we only have half an hour lectures for line planning because you want to play a little bit with it afterwards, then we cannot do too much stuff. So don't be afraid or worried. I hope that we can get through that together. For the structure of our lectures, so the first lecture will be the introduction lecture that I will give in a second. It will be rather short to give you time to play around with LinTim in general. So I will give you a short idea what LinTim is, show you how you can run it and how you can use it, and not really talk about the different planning stages here, just give you a general idea. And afterwards, you will have the first chance to create your own data set and play with the first exercise sheet that we gave you. You will do that again in the group work, so you will, yeah, we will again somehow do some real-life rescheduling of the groups, seeing that we get somehow nice group sizes for everyone. And then you can play around with it a little bit. Don't be too scared if you don't understand everything what happens in this first lecture, because I really want to get your feet wet a little bit so that you try out everything for the first time without really understanding what is now a mathematical line plan. But you will compute one anyway. And then afterwards, Anita will give the lectures for the different planning stages: line planning, timetabling, vehicle scheduling. And after that, there are special exercises regarding only this topic, so that you then get a little bit to know the different models that we use here, the different things here. So for the first exercise sheet, I just wanted to start with this. Don't be too afraid if you don't understand any word. I try to give you hints and somehow a nice introduction and walkthrough through LinTim without understanding everything first. But in the end, in the next part, you will get more to know in the next lectures what these different models are and what happened there. Okay, but I think let's start. So I just want to give you a first idea what LinTim is about. So in public transit planning, we already seen this. We have different planning stages. I just listed a few ones here. You heard about most of them from Markus already. And at least from the mathematician side of view, each planning stage on its own has been researched quite well. So there is specific research on timetabling and on line planning and so on and so on. And this goes very in depth, and there are many people working on that. But the problem is that it's hard to integrate the steps. So for example, if you want to examine the impact of one planning stage on the others, what happens when I change the line plan? What happens to the timetable and to the vehicle schedule? And that is often a disadvantage of this in-depth research, that when somebody is only working with timetabling, they have no chance to see what happens in the vehicle scheduling afterwards. And that's one of the goals for LinTim. We want to provide this integration so that you really can go through the whole planning process and see what happens. It is a collection of algorithms implemented in the diverse theses in our working group, but also some quite well-known algorithms from literature. It includes useful tools and especially the data format, so that everything is quite nicely controlled and we can have expected in and output for all things. And it is very modular, allowing people to change small things and working on, yeah, for example, the single planning stages without understanding everything else. And I made a small list of people who are currently involved with it, a nice mixture of student assistants, PhD students, postdocs, and Anita as our project lead. And with this picture here, I want to show you again this concept of analyzing the impact. And you see a little bit from a flow form. If you plan such a public transport system, you most often have some sequential process to do that. So you start at the beginning. Here, the first one is line pool generation and line planning. So creating the lines that are possible to use. And then you use this line that you chose to do the timetabling. And then you use this timetable to do the vehicle schedule. And I think with this flow, it's very clear that when you change something in the beginning, it's not clear what happens in the end. For example, if you find a very, very good line plan, there may not be any feasible periodic timetable at all. And that's something that you don't really see if you only look at the line plan. So it's very important to integrate this whole planning process to be able to just, if you do something in the beginning, just let it walk through and see what happens in the end with the complete public transport system and not just with your specific line plan or line pool or stopping pattern or whatever you're looking at. And with that, I want to give you an idea of LinTim itself. So what is LinTim? It's our software library, and when you open up the folder, I just made the screenshots yesterday in the virtual machine, so it will look more or less the same if you open it up in your virtual machine. We have some different folders at the highest level. We have CI for integration tests, data sets, which will be the most important folder for us today, where you will spend most of your time. Doc contains your documentation, where you probably will spend a little bit of your time if you want to look stuff up. Libs are some dependency, and source are the source files. So LinTim is an open source program. You can find the source files online as well if you would like to, and look everything up and see if it how everything works. So it's indifferent to something like PTV Visum, which is closed source. So you can try to understand what happens there, but with open source stuff, you really can look it up if you want to and are interested in it. Like I said, the most important thing for you today will be the datasets folder. This is where our datasets live. And we have different sizes available, and you can create your own. And you can see a short list here, what's currently implemented and what you have on your virtual machine. And the exercises will live on different sizes. So you will see that, of course, especially the harder optimization problems we will not do on the large data sets, because otherwise your virtual machine could not handle it or would need somehow, I don't know, 24 hours to compute stuff. That's not something we want to do today. So we will, of course, try stuff out on the smaller data sets, but there are some larger ones as well. And just for one example, I want to look at one data set in particular and see how it is built. So inside such a data set, this is toy. We have other subfolders containing the different planning steps. So for example, we have a specific folder for line planning, timetabling, vehicle scheduling, graphics output, delay management, and we have a basis folder. The basis folder is, again, maybe the most important today because that's the one that you will work in. There you can adapt the configuration, adapt the infrastructure network, and so on and so on. And afterwards, running things will use this makefile here. You don't have to understand how it works, just for those of you who know what this is. And with this, we will have a look at this basis folder. And in there, we then really have the datasets folders. So the dataset files. We have different files for the different things. We will explore most of these files today throughout the exercises. But maybe the most important and maybe the obvious stuff. So we have a stop file containing the stops, an edge file containing the links or edges. So for example, the tracks or the streets. We have an OD file containing the demand. So that's all things that you already heard about. One thing, yeah, exactly. What I want to show you today in particular is how these files are laid out. So all of our files in LinTim are plain text files, so you can open them up just in an editor and see how they look like. Check things for yourself, change things by hand if you like to do so, and yeah, understand what happens in your data set. Then how does such a file look like? Well, we have a comma-separated list, or in our case, semicolon-separated lists. So we see here a table form where the semicolon, separates the different columns. And in the beginning of the files, we always have some header where we say what happens in this file. So we have here that the first column is a stop ID, short name, long name, and coordinates. And that's what defines a stop in LinTim. If you're working with your files, please avoid having empty lines in between. There are some LinTim algorithms that have problems with that. Please don't do that. Put a hashtag sign in there to make it a comment or stuff like that. But this is how our files look like, and I think it's quite nice because you really can open them up and see what happens there and adapt them and add another stop and stuff like that without doing some magic. Another very important file for you today will be the config file. So we have different configuration files littered throughout LinTim. And the basic file is the config.cnf, where we have the baseline configuration for each dataset. For example, what is the name here? Here it's toy, so a little toy dataset. The period length of 60, the waiting time at a stop. You don't have to understand what all these things mean. If you want to look it up, all of these config keys are in the documentation, so you get an explanation of what these different things mean here. But again, for your exercise sheets, I try to always explain which config keys you want to change here and what they mean for those that you would like to use. Exactly. If you want to change things for yourself, just create a file called private config in this basic folder. You can read down here that this is included in this configuration file, and it's more or less the last. So anything you change in your private config will override everything else. So you can just create such a file to set different things. For example, such could look like this. You have your private config.cnf in the basis folder, and it just contains the things that you want to set. For example, here I set a model for the line concept, a model for the timetabling, and a model for the vehicle scheduling. You will notice that our config keys are always structured like this. So you have some kind of beginning that explains where in the world of public transport planning this config key lives, and then a short explanation of it. Again, if you want to look up what a specific config key is, you can just do this in the documentation. When you then want to run things, you again just do this in the dataset folder that you want to work with. For example, the toy dataset. And you can do this using a make command. Make is just a small kind of programming language in the Linux world. And you can just type in your terminal make whatever your command is that you want to do. Always my first hint is, please don't try to type these things out by hand. You have a tab key on your keyboard that is your friend. It will autocomplete stuff for you. And I will show it to you in a minute. If you want to get an overview what make commands are possible, there is the base make file containing everything, but I think you really don't need it for today. Just for reference, in the base make file, you can find everything that is possible to do. Our commands are structured similar to the config keys, so they almost always have some beginning that explains where they are located. So for example, make ptn and some things afterwards lc whatsoever. So for example, make lc line concept will compute a line concept. So again, on using the command, you see which kind of things are happening. And there are almost always evaluation tasks as well. So for example, LC line concept will evaluate a line concept and, for example, tell you how much does it cost, how many direct travelers do you have, how many transfers are expected, and stuff like that. And we will use these evaluation commands throughout the exercises. Maybe another word for the documentation. So this will be the first place for finding help and understanding stuff. Maybe next to just asking us, we will be here as well. And just to give you an overview for the planning steps, we almost always have some kind of two-step process to finding information. So first of all, you will find for every planning stage a short section just explaining in general what this planning stage is and what files are read and written and which models are there. And then you can find a detailed description for each algorithm explaining more in depth what this specific algorithm does and which config keys you can set and stuff like that. Additionally, there's things that you won't need today. For example, some first step tutorials in there, information on the data sets, information if you want to implement stuff yourself, but that's not something that we will cover today. And you can find this precompiled PDF in the documentation folder. So directly in doc, there is a documentation.pdf where you can look at and check it out if you have any questions regarding that. And how does it look like? Oh, that's not nicely with a nice resolution, but whatever. Just the introduction steps. So for example, for periodic timetabling, you then have a section in preparation, which command do you need to run first. You have a list of inputs files that your procedures may read. You have an output file that will be produced and the command that you need to run. So just to give an overview what happens in this planning stage and what files are read and read and stuff like and written and stuff like that. And with that, I want to switch over to my virtual machine. I tried to give it after the feedback yesterday, a little bit more of a font size stuff so that you can see things better. Yes, and I want to show it to you a little bit how you would use it in practice. So first of all, what I want to show everyone who is not using an US American keyboard, when you're opening up the settings, for me it now gets displayed here. Otherwise, you would need to change, need to search it. You can change the keyboard layout. We had some problems yesterday there, so I wanted to show it to you. So if you're in the settings, you may be in some subfolder when you start it up. I have not understand how this works yet. Then you would need to get back. If you have settings up here, down below you find region and language. And under input sources, you can then use the plus sign to add additional keyboard layouts. For example, for our German participants, there is a German option, which would be quite helpful. And then you can edit. And if you edit different stuff, you can either just delete the US keyboard or change up here the different layouts. So in the settings, region and language, input sources, if you're interested in that. Okay. Otherwise, I will open up the LinTim folder. I put some shortcut here. I noticed after installing it that naming the user LinTim is maybe a little bit confusing because then the home folder is called LinTim as well. But you have down here this with the correct spelling with L big and T big. This is the shortcut to your LinTim folder. And there you see more or less exactly what I showed you a second ago, the different main level folders. And then there we will look at the datasets folder and at the toy folder, which is the one that we want to look at today. And like I said, or like you've seen how the stop file, for example, works. So you will have time in a minute in your exercises to look at the different files and play around with it a little bit. I don't want to do this now. I more or less want to show you how you would use it, how you run commands, and how you see the output files. Because I think that's something that is interesting to see before trying it out yourself. And with that, what I always like to do is just right-click in the folder that I want to use. For example, I'm really in the toy folder. I have now the subfolders here. I can right-click and open in terminal, which opens up a new terminal here. And there I can now start to run my commands. The toy folder is somehow pre-processed, so I already have a line pool in there. Line pool means I have a set of lines that are possible to use. And with that, I can type in a command, for example, make lc line concept. You now have just seen tab at work. So I did not type everything by hand. I typed lc -l and press tab so that I cannot misspell it. I press enter. This will now take a little bit time at the first time because I need to compile anything. But afterwards, we can compute a line concept and we are done. We've seen a little bit of output here. We've seen that we have some timestamps. we have the begin execution of line planning cost models. So we see that it's obviously some cost-oriented model that is run here, and this produces a line concept. What this now does is it produces an output file. So in the line planning folder, we now have a file lineconcept.lin, which contains the line concept. So we can open it up, and we see again a header file or a header line describing what we see in the different columns. So we have line ID, edge order, edge ID, and frequency. And then we can see, for example, here that line 2, containing of the edges 2, 6, and 8, is used with frequency of 4, so a headway of 15 minutes. Of course, just looking at this line concept is not very helpful because at least I cannot see on this line concept if it's a good line concept. That's what we noticed yesterday as well. If you developed your own line concept, it's not so easy to find good lines. So we have some evaluation as well. So if I type make LC minus line concept minus evaluate, again using tab spaciously, maybe I will just explain to you how this works. So it will try to autocomplete your things. If you press tab and it doesn't do anything, it means it doesn't know your choice is not unique. You can press tab twice to see everything that is possible starting from there, and then you can type further and see until you find a unique solution that you can complete. Okay, yeah, just running the evaluation. Again, needs to compile some stuff at the first time. Up. And this again outputs something on the terminal, but more importantly, it creates some statistic file here. The statistic file now contains some evaluations. Again, for the meaning of the different things, some are, I think, quite self-explanatory. For example, LC average distance. You all probably have an idea what this means, or average edges, or average length, or cost. But if you want to look something up and see what it means exactly, you can look it up in the documentation. Yes. And what I want to show you, or what I want to focus with you now, is the cost of 51.2 and the objective direct travelers, SP. This means we have 1,580 people who can travel directly, so without a transfer, on their shortest path in this line concept, which is quite nice. What I want to do now is change it a little bit up. So I'll create this file basis/private config.cnf. Again, like I did yesterday with the knapsack programs, I open it up with gedit to get this file. You see that I did the screenshots yesterday. I will just remove it now. And change my model to a direct travelers model. So like I said beforehand, we had the cost model here, optimizing the cost of the line concept. Now we would like to see what happens if we're optimizing for the number of direct travelers, so the number of people who did not need to transfer in their shortest path. Again, I changed this model here, I saved it. And now I can type the same command as before, again, LC minus line concept. And now something different will happen. So it will not compute an cost line plan, but it will now use the direct model here, and we will have another line concept in there. So if I now open up the line concept, we see that we have a different line plan here. For example, line 1, which was not used before, is now used with frequency 4. And again, we can evaluate it. Reload the file. And we now see that we have a different line concept than we had before. So we now have a cost not of 51.2, but of 96. But we have more direct travelers as well, 1,860. I think we have 1,500 something before. So again, we can change parameters in the private config. changing the model that will be run using the same command will do something differently and find us different line plans. And now I just want to move with the default parameters through LinTim and see what happens. So the first thing that we would need to do next is make ERN. You don't need to write it down or stuff like that, so the exercise sheet will guide you through that. This will create an event activity network like I showed you on the first day. Afterwards, you can use tim minus timetable to create a timetable, which we then afterwards can evaluate as well. Just to give an idea what kind of timetable we computed here. So if you now look at the statistic again, reload, we now find some tim parameters here, where we now get an objective. For example, our passengers need 6.65 minutes on average perceived time to travel from their origin to their destination. And it's feasible. That's nice as well. After that, I would like to show you, as the last step, the vehicle schedule. For that, we will need another parameter in the configuration. Rolled-out trips will remove incomplete trips from our rolled-out period. So for the vehicle scheduling, we will now use our periodic timetable, repeat it throughout the day. In the default, it's from 8 to 12. And we don't want to compute vehicle schedules for incomplete trips, for example, trips starting at 11:55 and only doing one stop because we cut off at 12. So this will remove it. We will repeat our periodic timetable several times. Create the trip graph that I showed you on Monday. And computing the vehicle schedule. And again, we can evaluate it using the corresponding evaluate command. And now we have a look at the statistic file again. We see that we now have a bunch of evaluation parameters for the vehicle schedule. For example, we know that we need 17 vehicles to cover that line concept or timetable or so on. And that's very nice because now this is now the direct model that we looked at. I could now use the cost model in here as well, do the same things and see how much vehicles do I need to cover the cost optimal line plan and so on and so on. And maybe the last thing that I want to show you is one of our draw commands, for example, for the PTN. So we can use PTN draw, make PTN draw. This produces files in the graphics folder. And there you can see a nice depiction of our public transport network. Okay. So these are just the basic commands. I would like you to get in your breakout session rooms again. I hope one of Magdalena or Alex can open them up. And try out this first exercise sheet. Again, you don't need to understand everything that happens in these exercise sheets yet, because we will have the lectures concerning line planning, timetabling, vehicle scheduling later today. I just want to give you this first guide through LinTim, just doing it all by yourself. You create your own little data set. I don't know how many of you know the stories of Jim Button and Luke the engine driver and their adventures on Morroland, but you will model their small little island and compute there some first solutions. Yeah, this exercise sheet is thought that it should guide you through it a little bit, and see that you can try every command out, try changing stuff up, try changing your files, adding new lines, and see what happens and what solutions will you get. Exactly, the groups should be the ones from yesterday. Again, we will need it adapted a little bit ad hoc according to who is there and who's not. But we thought it would be nice if you could work together in your groups that you started to get to know yesterday.
And please feel free to ask if something is not working, because all the other exercises can then be based on the dataset you design now, right, for you. So you can try out everything we will do later with your dataset. or also with the standard data sets, but it's maybe more fun to have your own. So please feel free to ask if something is not working.
Yeah, exactly. So you will notice that some names of you from one of my first slides with the names working on LinTim are here as well. So Christopher Scholl is here, Vera is here, and they will help me a little bit with LinTim concerning questions. And we will also go through the breakout rooms as well and see how far you come along and if we could help you a little bit so that everyone can get a nice start with LinTim. Yeah, and then we will do that for, I think now it's an hour left. Then we make a break for half an hour. I think we will send one of those global messages to you that you know that. And then we'll meet again in 1.5 hours at 11 o'clock with the first lecture on line planning.